What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what the dynamic host configuration protocol is all about. So let's get into it. The dynamic host configuration protocol. This is a fundamental network protocol that plays a crucial role in managing IP address allocation and network configuration. DHCP, it simplifies network management by automating the process of assigning IP addresses and other network settings to devices on a network. And in this video, we're going to talk about DHCP in depth, covering its history, how it works, its components, security aspects, and its role in modern networking. All right, so what is DHCP? So like I stated earlier, this stands for Dynamic Host Configuration Protocol. It is a network management protocol used to dynamically assign IP addresses and other network configuration parameters to devices on a network. In DHCP, it automates the process of configuring devices to communicate on an IP network, ensuring that each device has a unique IP address and the necessary settings to operate correctly. And here's a brief historical context. So DHCP was developed to replace the earlier Bootstrap protocol, which required manual configuration of IP addresses. And DHCP was first defined in 1993 by the Internet Engineering Task Force in RFC 1531. It has since evolved with the current version defined in RFC 2131. All right, so let's talk about exactly how DHCP works. So DHCP, it operates on a client-server model where the DHCP server assigns IP addresses and network configurations to DHCP clients or devices on the network. And this process involves several key steps, and the steps are as follows. So you have the first step, which is discover. So when a device or a client connects to the network, it broadcasts a DHCP discover message to locate available DHCP servers. And this message is sent to the network's broadcast address and includes the device's MAC address. Then there's the offer. So DHCP servers on the network, they receive the DHCP discover message and they respond with a DHCP offer message. And this message contains an available IP address and other network configuration details, such as the subnet mask, default gateway, and DNS servers. All right, next is the request. So the client selects one of the offers and responds with a DHCP request message indicating its acceptance of the offered IP address and configuration parameters. And then there's the acknowledgement. So the DHCP server confirms the lease of the IP address by sending a DHCP ACK message to the client, and the client then configures his network interface with the assigned IP address and other settings. All right, so let's talk about what a DHCP lease is really quick. So the IP address assigned to the client is not permanent. It is leased for a specific period. So the client must renew the lease periodically to maintain its IP address. And the DHCP lease process involves two main steps. The first step is the renewal. So when half of the lease time has expired, the client sends a DHCP request message directly to the DHCP server to renew the lease. If the server responds with a DHCP ACK message, the lease will be renewed. Then there's this thing called rebinding. So if the server does not respond to the renewal request, the client continues to use the assigned IP address until 87.5% of the lease time has expired. At this point, the client broadcasts another DHCP request to any available DHCP server to rebind the lease. All right, so let's move on and talk about the components of DHCP. So several key components make up the DHCP protocol and facilitate its operation. So the first one is the DHCP server, and this is the server that manages the allocation of IP addresses and network configuration parameters. It maintains a pool of available IP addresses and leases them to the clients. And then you have the DHCP client, and this could be the device such as a computer, smartphone, or IoT device that requests an IP address and network configuration from the DHCP server. Then we have what is called the DHCP relay agent. And this is a network device such as a router that forwards DHCP messages between clients and servers, often used in larger networks where the DHCP server is not on the same local subnet as the clients. And then we have what is called a lease database. And this is a database maintained by the DHCP server that tracks leased IP addresses and their associated clients, ensuring that IP addresses are not duplicated. So let's quickly talk about DHCP options. So DHCP options, they provide additional configuration parameters to clients beyond the basic IP address and subnet mask. And some common DHCP options include the following. So you have option 1, that is your subnet mask. Option 3, that is your default gateway. Option 6, that is your DNS servers. Option 15 is your domain name. Option 51, this is the IP address lease time. Option 66, this is the TFTP server name, which is used for network booting. And you have option 150, this is the TFTP server address, which is also used for network booting. All right, so let's move on to talking about advantages of DHCP. So DHCP offers several advantages that make it an essential protocol for network management. The first is that of automation. So DHCP, it automates the process of assigning IP addresses and network configurations, which reduces the need for manual intervention and minimizes configuration errors. Then there's efficiency. So DHCP, it simplifies network management by dynamically allocating IP addresses from a centralized server, ensuring optimal use of available IP address space. There's scalability. So DHCP is suitable for networks of all sizes, from small home networks to large enterprise networks. It can easily handle the addition of new devices. And then there's flexibility. So DHCP, it supports various configuration options, allowing network admins to provide additional settings such as DNS servers, default gateways, and domain names to clients. Now, despite its advantages, DHCP does have some limitations and potential drawbacks. And the first one is dependency on the DHCP server. So if the DHCP server becomes unavailable, new devices will not be able to get a new IP address, and existing devices, they may lose network connectivity when their lease expires. Then there are security risks. So DHCP is vulnerable to certain security risks, such as unauthorized DHCP servers, which are also known as rogue DHCPs, and DHCP spoofing attacks, which can disrupt network operations. And then there are address conflicts. So in rare cases, IP address conflicts can occur if the DHCP server does not properly manage the lease database, or if multiple DHCP servers are configured incorrectly. All right, so let's move on and talk about DHCP security concerns. So given the importance of DHCP in network management, securing the protocol is crucial to maintaining network integrity and availability. And some common DHCP security concerns include the following. So you have rogue DHCP servers, and these are unauthorized DHCP servers that can be introduced into the network, providing incorrect IP addresses and configuration parameters to clients, which can lead to network disruptions. The next concern is that of DHCP spoofing. So attackers, they can impersonate a legitimate DHCP server, intercepting and altering DHCP messages to redirect traffic or launch man-in-the-middle attacks. And then there is IP address exhaustion. So attackers, they can flood the DHCP server with bogus requests, exhausting the pool of available IP addresses and preventing legitimate clients from obtaining addresses. Now, to mitigate these security risks associated with DHCP, you want to consider the following best practices. So you want to use DHCP snooping. So you want to enable DHCP snooping on network switches to filter and block unauthorized DHCP messages. And DHCP snooping, this allows switches to distinguish between trusted and untrusted DHCP messages, preventing rogue DHCP servers and spoofing attacks. Then you want to implement some access controls. So you want to restrict access to the DHCP server to trusted devices and users. And you want to use network segmentation and firewalls to isolate the DHCP server from untrusted segments. Then you want to monitor and log DHCP activity. So regularly monitor DHCP activity and review logs for suspicious behavior, and implement auditing to track and analyze DHCP requests and responses. And then you want to use static IP addresses for critical devices. So you want to assign static IP addresses to critical network devices like servers and printers to reduce dependency on DHCP and enhance security. All right, so let's move on and talk about some practical uses of DHCP. So DHCP is widely used in various networking scenarios, providing essential services for different types of networks. So we have home networks. So DHCP, it simplifies network configuration for home users, where it automatically assigns IP addresses and network settings to devices such as computers, smartphones, and smart home devices. Then you can find its use in enterprise networks. So DHCP is used in large corporate networks to manage IP address allocation and network configuration for thousands of devices, ensuring efficient and reliable network operation. Then you have ISP networks. So internet service providers that use DHCP to dynamically assign IP addresses to customer devices, allowing for efficient use of public IP address space. And then we have IoT networks. So DHCP, it can be used to configure IoT devices, ensuring that they can communicate on the network without manual configuration. All right, and next, let's talk about monitoring and troubleshooting DHCP. So effective monitoring and troubleshooting are essential for maintaining a reliable DHCP service. And here are some common tools and techniques. So you have DHCP logs. So you want to review DHCP server logs to monitor activity and identify issues. In these logs, they typically contain information about DHCP requests, leases, and errors. You have network sniffing. You want to use network sniffing tools like Wireshark to capture and analyze DHCP traffic. And this can help diagnose issues with DHCP messages and communication. You have some DHCP client tools. So you want to use DHCP client tools to release and renew IP addresses. And this helps to diagnose client-side issues. So you want to test DHCP server configuration changes in a controlled environment before deploying them to the production network. All right, so moving on, let's talk about the future of DHCP. So as network technologies continue to evolve, DHCP will remain a critical component of IP network management. However, the protocol may adapt to address emerging trends and challenges. So the first is that of IP version 6 support. So DHCP version 6, which is the version of DHCP for IP version 6 networks, this will play an increasingly important role as the adoption of IP version 6 continues to grow. In DHCP version 6, this includes features tailored to the IP version 6 address allocation and network configuration. Then we have the integration with SDN. So integrating with SDN, this will enhance DHCP's capabilities, allowing for more dynamic and programmable network management. You have IoT and edge computing. So as IoT and edge computing environments expand, DHCP will need to adapt to support the unique requirements of these distributed and resource constrained networks. And then we have security enhancements. So ongoing advancements in network security, this will influence the development of more secure DHCP implementations, incorporating stronger authentication and encryption mechanisms. And so to wrap all of this up, the dynamic host configuration protocol, this is an essential network management tool that simplifies the process of assigning IP addresses and network configurations to devices. By automating these tasks, DHCP enhances network efficiency, scalability, and flexibility. In understanding DHCP, this involves grasping its basic workflow, components, security concerns, and practical applications. By following best practices and leveraging advanced configuration options, network admins, they can ensure the reliability and security of their DHCP services. And as technology continues to evolve, DHCP will remain a foundational protocol, adapting to meet the needs of modern networks. So whether managing home networks, enterprise networks, or emerging IoT systems, DHCP, this provides a robust and reliable solution for dynamic IP address management and network configuration.